So the next type of study that we're going to talk about is a cross-sectional study, and you can see here on the evidence hierarchy again that we are slowly moving up the hierarchy. So cross-sectional studies are provide a little bit better evidence than ecologic studies, and so we're going to talk about why that is. So what is a cross-sectional study? So a cross-sectional study can also be called a prevalence study, because a cross-sectional study is measuring the prevalence of exposure and disease in a population. So it's looking at individuals, so that's one way that it's different from an ecologic study, and that's the reason that a cross-sectional study provides better evidence than an ecologic study, because the cross-sectional study does not have the limitations associated with collapsing across individuals and looking at aggregate data. So those are limitations, as we saw, that exist for ecological studies. So cross-sectional studies look at individuals, and they look at a single point in time, does the individual have both the exposure and the disease? So we have a defined population, and we just look at the proportion of the population that has the exposure and the disease at the same time. And so I like to use a camera as a sort of symbol for this type of study design, because the camera reminds us that it's a single point snapshot in time. Okay, so other study designs look over time, they measure individuals over time, but a cross-sectional study looks only at a single point in time. So again, the key thing about a cross-sectional study is that it's at a single point in time. Other aspects of the structure of a cross-sectional study are similar with other studies, particularly with cohort studies. So for any cohort study, we're going to start with a defined population. So we know exactly what population we're looking at, and then what we're going to do is divide the population into those who are exposed and those who are not exposed. So this shows the population. We have the overall population, and then we've now split it up between those who are exposed and not exposed. So we've separated those two groups. And this could be any exposure. So obviously, before we're doing the study, we have a particular exposure in mind that we want to look at and see the association with the outcome. And so now, naturally, we want to know whether exposure is associated with the disease. So what do we have to do? We have to look at the proportion of people in the exposed group who have the disease and compare to the proportion who do not have the disease. So right here, before you even look at the disease outcome, this gives you a measure of the prevalence of the exposure in the population, right? So as we know from learning about prevalence, we know that the prevalence would be the exposed over the whole population. The proportion of the population that is exposed is the prevalence. So here you see that the exposed group and the non-exposed group have been further broken down into those who have the disease and do not have the disease. And so you can see here that the proportion of diseased in the exposed group is higher than the proportion of diseased in the not exposed group. And that, in a correlational study, a cross-sectional study suggests that the exposure is associated with the disease. So this way of breaking down populations into those who are exposed and those with and without the disease should look familiar to you from many of the measures that you've learned about before. So we can display these numbers in a 2x2 table. So here you can see the 2x2 table. Remember that we've got disease in the first column, no disease in the second, and then exposure on the first row, and not exposure, lack of exposure, unexposed in the second row. So remember this table, because this is how you're going to calculate various measures, as you've already learned. But this breakdown over here is what happens in a cross-sectional study. And so the data from a cross-sectional study go here, and as we remember, prevalence can be calculated from this table. Okay, so here's an example of a cross-sectional study that was published in JAMA. This is from 2001. And what this shows is the relationship between diabetes and obesity in U.S. adults. So it compares here the prevalence of diabetes among obese adults versus non-obese adults. So you can see that the prevalence is more than twice as high in obese adults as it is in non-obese adults. So this suggests a relationship between diabetes and obesity. So what does this say? It says there's a correlation. There's a cross-sectional relationship between these two diseases. Okay, so down here we show the actual data. So this is the data from the paper. And in this study, there were about 195,000 people. And then those people were broken down into those who are obese. So of those 195,000 people, about 40,000 were obese, and the remaining were not obese. And then within obese, how many of those had diabetes? 6,490, and then the remainder is here. How many of those non-obese people had diabetes? And that's here. And then from here we can derive the prevalence of diabetes in obese versus non-obese. So we can see that the prevalence of diabetes in the obese is just the number of people with diabetes, number of obese people with diabetes, over the total number of obese people, which is 16%. And then similarly, the prevalence in the non-obese is just the number of non-obese who have diabetes over the total number of non-obese, and that's 5.7. So cross-sectional studies can give you this type of information: the prevalence of the disease in the exposed group and the prevalence of the disease in the non-exposed group. Okay, so here's another example of a cross-sectional study, and this study looks at the relationship between sedentary behavior and metabolic syndrome in U.S. adults. And so on the y-axis shows the percent of individuals in each exposure group who have the metabolic syndrome. So in this case, we have levels of exposure of screen time, so it's hours per day. And so this shows you can have more than 2 levels of exposure. So what we've talked about so far is you either have the exposure or you don't, but you can expand it. So like in this case, it's degree of exposure. And so here what this shows is that greater hours per day of screen time is associated with a greater prevalence of metabolic syndrome. And so this example illustrates one of the limitations of a cross-sectional study, because you see that you don't know here which of the variables causes which. So we've got metabolic syndrome and we've got sedentary behavior. So it could be that the more sedentary behavior you have per day, the more likely it is that you have metabolic syndrome. I mean, that the actually sitting around all day is what causes metabolic syndrome, okay? But it also could be that people with metabolic syndrome are less healthy, and so they have less ability to be active, and so they're sort of stuck on the couch because they're sick, and so they have more screen time. So the point is, you don't know the direction of the relationship between these two variables. You can see here that there is a relationship, but because it's only at a single point in time, you are not able to discern which of the variables causes the other. So that's why sometimes cross-sectional studies are called correlational studies, and I keep mistakenly calling them that, although it's not really a mistake. So they show a correlation between exposure and outcome, or between two variables, but they do not tell you what variable causes the other. They don't tell you the direction of causality. Okay, so quickly, the strengths and limitations of cross-sectional studies. So first, they're useful for generating hypotheses. So we saw that there's a strong correlation between obesity and diabetes that suggests the possibility that obesity might cause diabetes, or vice versa, I suppose. And similarly, we saw the screen time and metabolic syndrome relationship, which again generates a hypothesis for a more rigorous study to explore the causal relationships among those variables. Correlational studies, again, are inexpensive. Like ecologic studies, the data are often already collected, and so it's easy to just look for associations among variables. Useful for public health planning. If you see that that prevalence of particular things is higher in some groups, then that suggests how you could spend public health dollars. Also, what's good about cross-sectional studies is because you're looking at individual level data, you can measure associations among multiple variables. So usually, in a study, in a data set, you're looking at multiple variables at the same time. So you have multiple measurements on a single person, and so you can control for one variable while you're looking at associations among others. And so that's something that's beneficial about a cross-sectional study. And in terms of limitations, the main limitation of a cross-sectional study is that it provides no information about causality. And that's because there is no information about the time course of the variables, and because of a related bias called the prevalence incidence bias, which we're going to talk about in the next video.